Hi guys, I'm Abby.
And I'm Gail.
And in this video, we want to talk about some basic integration problems.
So we have problem number 1. So suppose we want to integrate 5x raised to the 4th power plus 4x minus 5 dx. I'm gonna do right now are going to indefinite integrals. The idea when there is pluses or minuses in between your terms, you can basically integrate them a piece at a time. First, we are going to take the antiderivative of 5x raised to the 4th power. So, the antiderivative of x raised to the 4th power is x raised to the 5th power. Because remember, you add 1 to that power. So, we have the integral of 5x raised to the 5th power. And also, divide that new power and we have divided by 5. Second, we have plus 4x. We take the antiderivative of x raised to 1, so you add 1, and we get 4x raised to the 2nd power, and divide it that new power, so we have divided by 2. Lastly, we have negative 5. The antiderivative of this 5 is 5x. So we have minus 5x. Remember, with indefinite integrals, you put this plus c. We can now simplify it to find the final answer. And that's the final answer. We have x raised to the 5th power plus 2x squared minus 5x plus c. As simple as that.
We have problem number 2. So suppose we have the integral of 3x minus 2 divided by the square root of x dx. The first thing I usually do on this problem is the same thing as if I was going to take a derivative. Any radical, I'll usually go ahead and write those as powers. So we're gonna rewrite this, the integral of 3x minus 2 divided by, so my square root of x I'll rewrite as x raised to 1/2 dx. At first sight, you may think, well, I'll just take the antiderivative of each piece, but as a rule of thumb, you use the same idea you would for taking derivatives. If you're going to take the derivative of 3x minus 2 over x raised to 1/2, you wouldn't take the derivative of each piece individually. You'd have to use the more complicated quotient rule for taking derivatives. While for finding antiderivatives, it's the same way. You can just find antiderivatives of each piece. But what you can do on this one is a little bit of algebra. You could rewrite this 3x minus 2 divided by x 1/2. So this is the integral of 3x divided by x raised to 1/2 minus 2 divided by x raised to 1/2 dx. At this point, I'm going to simplify things down. So 3x divided by x raised to 1/2. If I simplify x raised to 1 over x raised to 1/2, I'm left with 3x raised to 1/2 minus 2. If I bring the x raised to 1/2 to the numerator, it will become x raised to negative 1/2. And now this is in a suitable form for me to be able to integrate this. So again, the 3x comes along for the right. Okay, so we get the antiderivative of this. So we have integral of if I add 1 to the 1/2, I'll get 3x raised to 3/2, and then I'll have to divide by 3/2 minus. So if I add 1 to the negative 1/2, I get 1/2. So we have 2x raised to 1/2, and then I have to divide by 1/2. Negative 1/2 plus 1, 1/2. 1/2 plus 1, 3/2 dx. Okay, so we simplify it. So we have 3x raised to 3/2, and then we get the reciprocal of 3/2, and we multiply it. The reciprocal of 3/2 is 2/3 minus 2x raised to 1/2, and the reciprocal of 1/2 is 2. So dx now will become plus c. So this is the final answer. 3 times 2, 6, divided by 3, 2. We have 2x raised to 3/2 minus 2 times 2, 4. 4x raised to 1/2. Remember, with indefinite integrals, you put this plus c. So this is the final answer. We have 2x raised to 3/2 minus 4x raised to 1/2 plus c. That's all. Thank you.
Hope this video helped. Feel free to jump over to our website. Thank you for watching.